But what I wanted to show you before talking about that is the kind of safety that we can use. The one that we showed on the backside of that wagon in the cobot tending application in the video is one of these. This is a laser scanner from Schmersal, and it has a 270-degree field of view, which means that if we put this somewhere about here, and we define the field of view where we allow people to be and where we not allow people to be, then that will control the safety parameters inside the robot arm. Why am I showing this in this particular case? Well, as Ola said, we have 17 safety parameters and control programs inside the software of the UR. But those 17 parameters is only controlling the 6 axes of the robot arm, which means that it controls these guys. But in this case, we have a 7th axis. And this 7th axis is not overwatched by the control system of the UR, which means that we need to implement some sort of safety measure to make sure that we don't kill anyone getting stuck in between the robot with that 7 axis. If I trigger this one, then it will trigger a remote stop, and it will stop the movement of the 7th axis as well. But if I get squeezed in here, I get stuck with the belt, I get stuck with my hair or something, then we need to trigger a protective stop. And this guy does not know when that happens, which means that it's better to implement some kind of safety fence. The other way of doing that is using something like this. This is a light curtain as opposed to a light beam. A light beam has 1 or 2 or 3 or 4 beams. This guy has a distributed field of beams with 30 millimeters in between. And if you go into the safety standards, you can always define on, okay, how is the robotic implementation or the automated cell gonna be handling, what kind of body part do we want to have in conjunction with the cell? And then you'll define what kind of beam distribution you need, etc., etc. But this guy can then be used exactly as the safety scanner. So we would put this in front of an application like this, and then if we break that curtain, then it's going to pause, and then when you move out, it's going to continue. So what this guy does is it's just picking a little plastic piece. It's then moving with the slide over to a position where it's going to be putting it into the vise that we put down here. The vise is gripping it, it's telling it I got it in position, you can move out, get a new part. It's picking a new part, and what we have here is the same kind of palletizing patterns as we are using over there. So it's the same easy way where we're teaching 4 corners in this case. And then now it knows that it's in the vise, so it needs to change the TCP, get the part with the other gripper, put the other part into the vise, and then go back and palletize the finished part on this palletizing pattern over here.
Wow.
So we have one depalletizing pattern here, we have one palletizing pattern here, and then we have a feature over here with the vise. So think of it as being inside a lathe or inside a grinding machine or a milling machine over there, and we need to move. Maybe we need to tend 2 different machines with the same robot. Sure, let's just hang it upside down and do that.
Så bra.
Okay, let's go over here.